This is part 2 of solving fractional equations. Only the questions highlighted will be mentioned in this video. This video is meant for checking purposes. Question 1. We can expand the terms first. So we will get 10p plus 28 is equivalent to 3 minus 15p. To solve this equation, we can add 15p on both sides. So on the left-hand side, after adding 15p, we are left with 25p. And the right-hand side, when you add 15p, it forms a zero pair and you have no more p terms. The next step, we can subtract 28 on both sides. So the left-hand side, you're left with 25p. And on the right-hand side, you subtract 28. And you will have negative 25. So the value of 1p, you need to divide by 25 on both sides. So upon dividing, you are left with 1p is equivalent to negative 1. Do note that there are many ways of solving an equation, so this is only one of the methods. Question 3. For this question, we have to add the two fractions first, since there are two terms with w. So the common denominator of 3 and 5 is 15. So the first fraction, you multiply by 5. Second fraction, you multiply by 3. So you have 6w. So numerator, you get 11w over 15. On the right hand side, you get 55 over 1. So for this method, I can rewrite 55 so that I can have the same denominator as the left hand side, 15. So with that, we can multiply 15 for the numerator and denominator this way. So we will get 825 over 15. So this implies that the numerators are equivalent. So I can divide by 11 on both sides. So I'm left with 1w is equivalent to 825 divided by 11. And using the calculator, we will get 75. Question 6. Question 6. The lowest common multiple of 7 and 2 is 14. So on the left hand side, I need to multiply the numerator by 2, denominator by 2. On the right hand side, I have to multiply the numerator and denominator by 7 each. So let's simplify this. Numerator, I will get 30 minus 40p over 14. On the right hand side, we will get 49 minus 21p over 14. Now that the two fractions have the same denominator, it would imply that their numerators are equivalent. So therefore, 30 minus 40p is equivalent to 49 minus 21p. So let's simplify this. So I can add 40p on both sides to form a zero pair. So on the left hand side, you are left with 30. No more 40p because you can form a zero pair with positive 40p. On the right hand side, I have to add the 40p. So upon evaluating the right hand side, negative 21p plus 40p, you will get positive 19p. You can press the calculator to check. The next step, we can subtract 49 on both sides. So 30 minus 49. On the right hand side, you have positive 19p. So upon evaluating this, you get negative 19 on the left. The next step, you can divide both sides by 19. So negative 19 divided by 19 is equivalent to 19p over 19. Let's divide this. And we will get negative 1 is equivalent to 1p. Question 7, we can distribute the 2 first. So we will get 2x minus 2 over 3 plus 3x over 4 equals to 0. So for this question, I can combine the two fractions together. The lowest common multiple of 3 and 4 is 12. So that means the first fraction I have to multiply by 4, and the second fraction I have to multiply by 3. So let's simplify this. We have to distribute the 4 in and positive 3 inside. So we will get 8x minus 8 plus 9x over 12 is equivalent to 0. So the numerator on the left hand side, we will have 17x minus 8 over 12. On the right hand side remains 0. So for this question, there are a few ways of solving this. So to get the same denominator, I can multiply by 12 on both sides. And we will get 0 over 12, because 0 times 12 is still 0. Okay, but the right hand side, essentially, it is still 0, because 0 divided by 12 is still 0. This fraction is still valid. So hence, since the two fractions have the same denominator, it implies that the numerators are equivalent. So 17x minus 8 is equivalent to 0. So we can add 8 on both sides. So 0 plus 8 is 8. Then we can divide by 17 on both sides. So we will get 1x is equivalent to 8 over 17. Question 8. We can combine the two fractions again. Take note there's a subtraction sign. So do expect that there will be a change of sign. So the lowest common multiple of 7 and 3 is 21. So the first fraction you have to multiply by 3. Minus, use brackets. The second fraction you have to multiply by 7. So let's expand this fraction. We will get 18x plus 3. Then minus 14x. Please take note that you're expanding negative 7 inside. So there will be a change of sign. We will get plus 49 divided by 21. Okay, so let's simplify this fraction on the left hand side. We will get 4x, 3 plus 49, that will give us 52. For the fraction on the right hand side, I want the denominator to be 21, same like the one on the left. So I have to multiply the numerator and denominator by 21. So this will give us 84 over 21. Since the two fractions have the same denominator, it implies that their numerators are equivalent. Then we can subtract 52 on both sides. And we get 32. Next we can divide by 4 on both sides. We will get 1x is equivalent to 32 divided by 4 is 8. Question 10. 12 divided by x is equivalent to negative 4. You will notice that the x here is in the denominator. So the method that I'll be using is the same as before. Okay, I want to have the two fractions to have the same denominator. So negative 4 is a rational number. It can be written as a fraction, negative 4 over 1. So in order for the fraction to have the same denominator x, I need to multiply the numerator and denominator by x. Hence, on the right hand side, I will have negative 4x divided by x. Since the two fractions have the same denominator x, it implies that the numerators are equivalent. So 12 is equivalent to negative 4x. To get the value of 1x, you have to divide by negative 4 on both sides, because the coefficient of x here is negative 4. So I can do it this way. 12 divided by negative 4. The right hand side also divided by negative 4. So the negative 4 can divide by negative 4. You get positive 1. So right hand side you're left with 1x. Left hand side you're left with negative 3. Question 11. We can use the same method as before. So this means that I have to multiply the right hand side by x minus 2 for the numerator and the denominator by x minus 2, so that both fractions will have the same denominator. So on the right hand side I will have 8x minus 16 over x minus 2. So this implies that the numerators are equivalent. Next step, I can add 16 on both sides. So I will have 56 is equivalent to 8x. Then I can divide both sides by 8. So on the left hand side, I will have 7 equivalent to x. Question 12. The lowest common multiple of the two denominators is 6 multiplied by 3x plus 15. So on the left hand side, we have to multiply the numerator and denominator by 6. On the right hand side, you have to multiply by 3x plus 15 for the numerator and denominator. So we will get 42 in the numerator. It is not necessary to expand the denominator, because since the two denominators are the same, it implies that the numerators are equivalent. Okay, so we can subtract 15 on both sides, and we get 27 is equivalent to 3x. So to get 1x, you have to divide by 3 on both sides. So 27 divided by 3 is 9. So x is equivalent to 9. Question 13. 2 will subtract a fraction, then you add another fraction. This 2 is a rational number. We can write it as 2 over 1. So for this question, you can combine all three fractions together, and the lowest common multiple of 3 and 5 is 15. So 2 will need to multiply by 15, subtract. You have to multiply by 5. Take note there will be a change of sign because of this subtraction. So 5 multiplied by x plus 3, then plus the third fraction you have to multiply by 3. Let's expand the numerator. Take note that you are expanding this. You have to distribute negative 5, not just 5. So negative 5 times 3, you get negative 15. So on the right hand side, if I want 0 to have the same denominator as 15, I can multiply 15 on both sides. So on the right hand side, 0 times 15 is still 0. Denominator is 15. On the left hand side, upon simplifying, you can use the calculator to help you check. 30 minus 15, you get 15. Negative 5x plus 3x, you get negative 2x. So this it implies that the numerators are equivalent. We can add 2x on both sides. So 15 is equivalent to 2x. Next, we can divide by 2 on both sides. So 15 divided by 2 is 7.5. 2x divided by 2 is 1. So you get 1x. You can leave your answer as 7.5 in decimal, or you can write it as a fraction, 7 and a half, a mixed fraction. You must convert your improper fraction into a mixed fraction or a decimal. Question 14. Let's observe the question. You will notice that there are two fractions with x terms in the denominator. So we can combine the two fractions together using the same principle as before. The lowest common multiple of 2x and 5x is 10x, not 10x squared, because we want the lowest common multiple. So the first fraction you have to multiply by 5, and the second fraction you have to multiply by 2. So we get 25 minus 14. So upon simplifying this, we will get 11 over 10x is equivalent to 2 over 3. At this stage, we want these two fractions again, one on the left and one on the right. We want these two fractions to have the same denominator. The lowest common multiple of 3 and 10x is 30x. So in order to get 30x, on the left hand side, you need to multiply by 3 for the numerator and denominator. On the right hand side, you have to multiply by 10x for the numerator and denominator. So we get on the left hand side 33 over 30x. On the right hand side, we get 20x over 30x. So since these two fractions have the same denominator, it implies that the numerators are equivalent. We're not doing any cancellation here. The next step, we have to divide by 20 on both sides. Now this fraction is an improper fraction, so we need to simplify it. So therefore, x is equivalent to 1 and 13 over 20.